Welcome to another Okie Dokie Tech video, this time featuring the Indiedroid Nova sold by Ameridroid.com. I bought this with my own money in April of 2023, so this is not in any way a sponsored video. It's not even a very new product, but for the present, as of January 2025, the RK3588S seems to still be the most recent ARM SoC that's available to buy. There are some pre-orders out for new ARM v9 boards that may be shipping this spring, but I've not seen one to buy right now. Again, this is a Rockchip RK3588S based single board computer. This one has 16 gigabytes of RAM and came with a 64 gigabyte eMMC drive, and it came pre-assembled except for the fan, which is easy enough to install with the provided screws. All you do is push down the red wire on the red pin, because these pins are color-coded, and the black wire on the black pin. It's still being sold as of January 2025 and is currently priced at $179.95 plus taxes and shipping. Some of the highlights of the specifications are that it is an 8-core processor that can ramp up to 1.8 gigahertz on 4 of the cores and 2.4 gigahertz on the other 4. And it has the ARM Mali G610 GPU that is supported with the Panfrost drivers. Another thing of note is AI accelerator, 6 tops, and the RAM is LPDDR4X. The storage is eMMC 5.1 flash connector, and it is not soldered to the board and can handle at least 256 gigabytes of storage space. Of course, it has a TF card slot and has 2 USB 3 connectors, the A-type, 2 USB 2 connectors, the A-type, Ethernet, and on the side here we have the power port, micro HDMI, and a USB-C port and an audio port, which is being left off of a lot of devices these days. You may also notice that the GPIO pins are color-coded, which is very nice, and the color coding matches that of the Raspberry Pi. The 5 volt, 3.3 volt, and ground pins are identical, although the other pins are not necessarily the same. So some hats that work with Raspberry Pi may work with this, and others may not. This is not exactly an unboxing video, but I did want you to see that the Nova came in a nice plastic box. We can disassemble this by removing the 4 screws here. They go all the way through the 3 layers with the SBC sandwiched between the 2 sides of the heatsink case. And there we go. Let's lift up the top layer. It's stuck down a little bit with the thermal pad, and the thermal pad is still very pliable and soft, even though it's been on there for a year and 9 months, which is good to see. One thing to mess around with on this computer is installing an RTC, real-time clock battery. It just uses a typical 3-volt CR2032 coin battery with a pigtail lead that has to be threaded through the heatsink to attach it to the little board. So it's through the heatsink, and it goes this way. And there it is attached. Also, we need to put this back on, or two other things of note on the board are this right here, which is a MIPI CSI camera port, and this, which is a MIPI DSI display port. And then we've got these 4 buttons here that are labeled power, reset, recovery, and boot, I believe, but I don't ever use those. So now we can just set this back on top. On the other side of the board, we have the eMMC drive, and it's very easy to just put your fingernail up under it and take it off, and it can be replaced with another eMMC drive. You just line it up over top of the outline carefully, and you can feel when it plugs in. Upgraded to a 256 gigabyte eMMC drive. To flash your operating system, you're going to need a eMMC flash writing device, and I have one right here. I have a USB one, but I can't find it. This one plugs into a TF card reader, and you plug it into your computer and can write to the device. The device itself, the eMMC drive, just lays on top of there, and these two connectors are not the same size, so look at them carefully. The shorter one is up near the top, and you can feel when they're in place, and snap them down, plug it into the card reader, and flash your OS. I've used Bellina Etcher a number of times in the past to write the image to the eMMC, but for some reason it failed 3 times, and I ended up using Rufus, which worked perfectly. I'm not sure why that happened. If you do not have a eMMC flash writer, I've just discovered an Indiedroid wiki page with instructions for writing an image to a TF card first, then copying that image from the TF card directly to the Nova without removing the eMMC drive. This is much more convenient since many computers have TF card readers. I've not tried it yet, but it should work. Hopefully this method will be helpful to some people. Check out the Indiedroid wiki page for details. I'll have the page link posted below. I ended up with Ubuntu 22.04 Jammy Jellyfish installed on the 256 gigabyte eMMC drive, and as far as I can see, only the USB-C display port does not work as a display port. It works as a USB-C port. If I look at the results of the command USB devices in the terminal, it shows that the USB-C port, bus 8, is USB version 3.0. A Lexar USB-C drive was plugged into that port on the Nova. As you can see, the Lexar was detected as supporting USB version 3.2, but the USB port it was plugged into is still only detected as USB version 3.0, so data will only be copied at USB 3 speeds. Even though I'm only about 8 feet from my router, I generally get download speeds of about 120 to 122 megabits per second. I would really like to have faster speeds. If we look more closely on here, right here is our Wi-Fi Bluetooth radio. Right here is the built-in antenna, and right here is a IPEX antenna connector. So I was hoping that I could connect the antenna that would give me faster internet speeds. I tried this antenna. I tried 2 flag antennas, and I have this IPEX to SMA cable, and with it tried 3 of these type antennas, that one, this one, and this one. Unfortunately, none of them got any better of a signal than adding maybe 10 megabits per second to the speed. I did not really expect great results from trying random antennas, because antennas are not one-size-fits-all devices. They need to be engineered for the radio that they connect to. But I can't help but think that if I found the right antenna, there could be a nice bump in Wi-Fi speed. Now, before assembling, since the GPIO pins are exposed on this case, I've put some non-conductive silicone on the edge of the bottoms of the pins in case something inadvertently touches them to prevent accidental shorts. Now, I'll reattach the bottom. Then, for a nicer look, I've made a metal cover to go over the USB ports and the Ethernet port. And you'll notice that there's a gap right here where the Ethernet port is shorter than the USB port. So I have a thin piece of wood that I'm going to color black with a marker, and I'm going to attach all of this with double-sided adhesive. You can also make this cover out of plastic instead of metal, and you can use cardboard colored black instead of wood. To further protect the GPIO pins from accidental shorts, I also ordered a silicone cover for the GPIO pins, and I used a razor to cut away part of the silicone where the fan pins will attach. So we'll put that down there. The heatsink is very effective without even attaching the fan. The house temperature is 71 degrees Fahrenheit, and without the fan connected, I did a series of tests. The idle temp on the Nova was 42 degrees centigrade. Thermal throttle is about 82 degrees, and that was not reached even when running Stress NG. The highest temp, and that was from running Stress NG all cores for 60 seconds, was 74 degrees. But now let's put the fan on. Just for looks, I'm going to take a marker and color the red wire black so it's less noticeable. I've gone ahead and used the black marker on the red wire going to the RTC battery as well. And I also like this battery not to look quite so obvious. So I'm going to try to turn it into a rectangle instead of a circle, that is, and attach it to the side of the Nova. And I think that will be a little easier to blend in. So let's do that. Bring this around like that. Now I'm going to wrap some black tape the other way. I'm using a different tape for the other direction because this one's not wide enough. We see here the reassembled all-black Indiedroid Nova with the RTC battery attached to the side. One day I may find a nicer looking black plastic battery case. If so, it's easy to remove the tape and put the battery in that case. Just so you can see how tiny this computer is, here it is next to a deck of playing cards. The footprint is slightly smaller in both directions, but the computer, even if I remove the fan, is still thicker than the deck of cards. The 64 gigabyte eMMC drive that came pre-installed was flashed with Armbian. I have Ubuntu 22.04 Jammy Jellyfish flashed to the 256 gigabyte eMMC drive that I bought. The Nova lacks the M.2 connector that would let you attach a much faster NVMe drive, but the eMMC drive feels pretty snappy anyway, and it's certainly faster than a micro SD or TF card. Jammy Jellyfish runs an older 5.10 kernel, but this will be supported until 2031, so there's no giant hurry to get a newer kernel. Anytime I want to try a new image, all I have to do is to flash it to a TF card. If you have a bootable TF card installed, the Nova will boot first from the TF card, letting me try new images without installing them to the internal eMMC drive. And there are many images being worked on. I counted 50 images to try out. They include Armbian, Debian, Ubuntu, Not Quite Kali, Bread OS, Arch, and Android, among others. Check out the software page for Indiedroid to find those images. Many images lack support for one or more of the following: Wi-Fi, Bluetooth, sound, USB, or Widevine. So be sure to look for which images are in development and check out those issues and notes before installing. That finishes this video. If you've enjoyed it, please like and subscribe, and I'll see you with a new video next week.